I don't know when they used to say that, but they said it at some point. Okay, so we got the rate at which rainwater flows into a drain pipe, and we have an equation. So automatically, rainwater rate. Okay. Oh, into goes into it. Uh, in cubic feet per hour, the pipe is partially blocked, allowing water to drain out, and it's gonna drain out at a rate modeled by D of T. Bum, bum, bum. There are 30 cubic feet of water, so there's already water in the pipe. That is our initial condition. Now, you know what? Let me even write it right here, 0, 30. How many cubic feet of rainwater flow into the pipe during the 8 hour? So, one of the common mistakes here for A was that people used the initial condition. We're not asking how much water is in the pipe, just how much water flowed into it. So this is the integral from 0 to 8 of R of T dt, which is approximately 76.57 cubic feet of water that flowed into it. I'm not going to write the full sentence. Just leave it like that. I'm going to leave it like that. You guys write the sentence. Is the amount of water increasing or decreasing?
Take the derivative. BQ.
Yeah, because how many cubic feet? It's there's a volume of water here. Take the derivative, you said?
So you do your initial plus the amount of rainwater floating. That's what happens.
When you say the initial,
Huh?
when you say take the initial,
Oh, wait, no, I'm tripping.
we already have the rates, right?
Yeah. No.
We just need to figure out the rate at which water is flowing in, which is well, actually, I didn't even write it, but you can do this separately. I did R of 3 minus D of 3, but you can do them separately to figure out which one's greater. And R of 3 minus D of 3 is approximately negative 0.3136. And because that's less than 0, it's decreasing. So the common mistake that I saw was that people took derivatives, but they were already derivatives. Rainwater is decreasing, or rainwater in the pipe at T is equal to 3 because R of 3 minus D of 3 is negative. It's less than 0. At what time is the amount of water at a minimum? First, you kind of need an equation to figure out quantities. So the general equation for this is this. Now you actually have to use your initial condition. Because we're trying to find a minimum, the general steps are like take a derivative, and then
Find them.
critical points. So right now we already have our derivative, right? We know water is flowing in, R of, is it X or T? T. So we have R of T, rainwater is also flowing out. That's basically already our derivative. You set it equal to 0. You use your calculator and you find the critical points, which happen to be 0 and 3.2717. Now,
you don't add the initial condition?
Not yet, because this was the derivative. But we are going to use it now that we're trying to find our minimum. Because you can make a table. They always make tables on the rubric. But again, you also don't have to. The amount of rainwater. So we have our critical point. We have our other critical point. And we should have an endpoint. 8. You use your endpoints, you use your critical points. You're basically plugging the critical points and the endpoints into this. But that's just the general one. For us, we should have this. The integral from 0, because that was the initial condition, to 0 of r of t minus d of t dt. Now you use the initial condition, which was at 30, right? 30. Plug it all in the calculator, and you get 30. That one we already knew. There was 30 cubic feet of water. Plug in the other one. And technically, you don't even have to show this work on the table. I'm just showing you guys. You can just complete the table with the answer, which is 27.965. The last one is 48. Now we know which one's the minimum. The water's at a minimum at 3.2. Minimum water in pipe at t is equal to 3.2717. Okay, last one. The pipe can hold 50 cubic feet of water before overflowing. For t is greater than 8, water continues to flow in and out. Right, but don't solve an equation involving one or more integrals that gives W, which is the time when the pipe begins to overflow. First mistake was people made the integral from 0 to 8. We don't know if it's going to overflow during that time, right? We need to figure out a time when it overflows. You have to consider the water flowing in, consider the water flowing out. You have to consider the initial condition, because we don't want water to go beyond 50 cubic feet. And at this point, you could set it equal to 50. But in order for it to overflow, this has to be more than 50, right? Because if it hits 50, technically still good. It hasn't overflowed. So you could also do this. And that will help you figure out when it's going to happen. Yep, that's it. Next group. Thank you very much. We are going to jump into, I already did number 2, even if you already did it. Number 3, I believe. Let's see. Yeah. Oh, yep, there it is. It's blank. Okay, while you guys take out your test, we have a problem where Joanna jogs in a straight path. Her velocity is given. We have selected values in meters per minute, so it's a rate. Of course, it's velocity. We want to approximate v prime of 16. So, as I'm sure you guys already know, to approximate v prime of 16, all you got to do is exactly take the average rate of change. The answer here, I'm going to skip the work, but v prime of 16 is approximately 5 meters per minute squared, because it's the rate of a rate. Okay. 1 point. Okay. It's not much, but every point counts. B, using the correct units, explain the meaning of that integral, and then I approximate it using the right Riemann sum. So, what's the meaning of the integral? The total distance traveled, jogged, whatever you want to say, during, is it minutes? Yes, it is. During minute 0 and 40, or during the first 40 minutes, however you want to phrase it. Now let's actually do it. the integral from 0 to 40 of v of t dt using the right Riemann sum. And you know what? I'm going to use function notation to, instead of keeping it simple as base times height, function notation, it would be, the base would be 12 minus 0. And then we're going to be using f of 12 because that's the right one. Then you have 20 minus 12 times f of 20 because that's the right one. 24 minus 20 times f of 24 plus 40 minus 24 times f of 40. So here we got 12 times 200 plus 8 times 240 plus 4 times negative 220. Good catch. Plus, what is it, 16 times 150. It is going to be the absolute value because we're not finding displacement. So traveling backwards, it counts as traveling forward. So, oh, there was no calculator, huh? Well, you guys can multiply all those by hand. I'm just going to tell you that the answer is 7,600 meters jogged. During the first 40 minutes. Interestingly enough, the setup was correct in a lot of people's work, but we didn't end up making mistakes. Not everybody got 7,600 who set it up correctly. All right. Algebra. This one was a total of 3. One for the explanation, one for the setup of the right Riemann sum, and one for the answer. So we have Bob. He's riding his bicycle from 0 to 10. His velocity is given. Find his acceleration. Okay. Not too bad. We just got to take a little derivative here. B prime of t equals 3t squared minus 12t. Oh, the 300's gone. Plug in the 5. 25 times 3 is 75. 12 times 5 is 60. So 15. 15 meters. And there you go. Thanks. 2 points. Derivative, answer. Okay. And then the last one. D. Find the average velocity. Some people are confused here. So we're given velocity. And we want to find the average velocity. That just means find average value. So 1 over 10 minus 0, the integral from 0 to 10 of Bob's velocity, which is t cubed minus 6t squared plus 300. You get 1 point for the setup. You get 1 point for the antiderivative. From 0 to 10, and then you're going to get 1 point for the answer. I'll skip, I don't know, should I skip the algebra? Maybe not. 1 over 10, 1 over 4, and then 10 to the power of 4, that's going to be 2 to the power 3 to the power of 4, 10,000, minus 2 times 1,000, plus 3,000, minus 0. So now we have 1 over 10 times, you know what? Let me distribute that 1 over 10 because the numbers are kind of nice. Because if I distribute the 1 over 10, I get 1,000 minus 2 times 100 plus 300. 1,000 divided by 4. So that should give us 350. Come on in. Yeah. 350. And because we're finding the average velocity, the units are meters per minute. There you go. Last point. So That's number 3. Wait, for part C, what? Oh, did I? Why? Oh, it's meters per minute. Thank you, thank you. Meters per minute squared. Good catch. Thank you, thank you. Thank you very much. Who's sitting right there? Marisol? Okay, she's testing. You guys get to do number 4 with me. Okay. Quick second. Number 4. Okay, I have 7 minutes. I think I can do it. So first, make a slope field. That one, almost everybody got it right. Almost everybody got full credit. I'm just gonna do one of the little slope fields. Like for example, this point, 1,2. Well, all you gotta do is plug in the point 1,2, which is 0, and you sketch the line, right? So I'll skip that one, but I'll tell you what they look like. This one looks like this. This one looks a little steeper. This one is kind of like that. Notice how there's no points here. If you put points, I didn't penalize you for it, but yeah, it says provide the 6 points indicated. Right. So anyway, this one is like that, and this one is like that. B, find the second derivative in terms of x and y. And we already have the first derivative. dy dx equals 2x minus y. So the second derivative, because we're taking a derivative with respect to x, 2, and some people wrote dx dt or something else, but it's just 2 minus dy dx. But it said in terms of x and y, so you can't leave the dy dx like that. So for dy dx, substitute what we already know, which is 2x minus y. My second derivative becomes 2 minus 2x plus y. Yep. There's 2 points for part A, 2 points for part B. Okay, part C. F of x is the particular solution to the differential equation with an initial condition. Does it have a relative minimum, maximum, or neither? I feel like we already did something similar to this. Yeah. Oh, sure. Is there a second part? Determine the concavity for all the solutions. Oh, thank you. Good catch. Good catch. That's what I get for not reading the full question. Reminds me of somebody else I know. Okay. So determine the concavity of all the solutions in quadrant 2. In quadrant 2, the x's are negative and the y's are positive. So no matter what point you plug in, the second derivative will be 2 minus 2 times a negative number plus a positive number, which gives us 2 plus 2 times whatever the number is, right? You know what? I'll put an x here, negative x. And here I'll put a positive y. So everything's positive, no matter what number you choose. So determine the concavity. The function is concave up because the second derivative is always positive. Okay. Ahora sí, thank you. Good catch. Let's see. Do we have a minimum, a maximum, or neither at 2? Thank you. It's probably Rosa. So if I take my differential equation, which is 2x minus y, normally you guys want to set it equal to 0 to find the critical points. But we're not looking for critical points. We already are given a point. So just check if it does give you 0. You know what? Does it equal 0? Let's see. 2 times 2 minus 3. That is a 1. So it's not even a critical point, which means you can't have a min or a max. Neither, because dy dx does not equal 0. D. Find the values of the constants m and b such that y equals mx plus b is a solution to the differential equation. When something is a solution, it basically means that it's antiderivative, given the initial condition, right? So, for example, if I give you a function sine of x, its derivative would be cosine of x. So sine of x is a solution to the differential equation cosine of x, because it's its antiderivative. Okay. So we have y equals mx plus b. If I take the derivative, dy dx, what do I get? M and b are supposed to be constants. You get m. We also know that dy dx is 2x minus y. So set them equal to each other. That's already 2 points. One for the derivative and one for setting them equal to each other. I don't really care about y. We want to solve for m and b. So take the y and replace it for mx plus b. Distribute the negative. And the m on the right side, bring it over. So subtract the m. So we need values for m and b to make this whole thing equal to 0. Well, look at these guys. They have a greatest common factor. You can factor out an x. And then for the second group, we can factor out a negative. So again, we need both of these groups to basically be 0. Because if they're 0, then you're going to get x times 0 minus 0. And you're going to get 0. So set the 2 minus m equal to 0. And that's your first value. Set the b plus m equal to 0. And we already know that m equals 2. So then in that case, b equals negative 2. Okay. Just in time, because my timer just went off. So thank you very much. Hasta luego.